What you see in the video is an example of a castellnut and a castellated shear nut. What I hold in my hand is a castellnut. You can see the length of the nut is longer, and the castellations, the slots and the material after the slots, these castellations are longer. And what you see in this part here is a castellated shear nut. These are the two big difference between this castellnut and castellated shear nut. In shear nut, the length of the nut is smaller and the castellations are much smaller. The gaps are there for installing the cotter pin like this, and this is the big difference between the two nuts, and it has to be installed in right location. This castellnut can hold high tensile loads. It can be installed in high tensile applications, whereas castellated shear nuts have very small castellations. That means they has to be installed in shear applications. So when you look at this part of the aircraft, now where this nut is holding, can you see clearly? Here we have the bolt and the nut is installed here, and this is the part. When this landing gear is going to retract into the aircraft, this portion is going to get pulled, whereas this portion is going to resist. So there are two forces acting here. This portion is going to pull and this portion is going to resist. So this location we have two parallel forces acting, one that is trying to pull and one that is trying to resist. So these two parallel forces is what we call as shear. Now in this location, since we have shear forces acting, we cannot use a castellnut because this is designed to take high tensile loads. Whereas this one, in location like this, we have two shear forces acting on both sides. So we have double shear. So in case of that, we have to use castellated shear nut. The castellations are smaller and the nut is more broader compared to the length. This can take very high shear loads compared to tensile loads.